This video is going to run through the problems on the classroom, the in-class practice problems from section 1.1, which we should have gone over, but I want to make sure you have a reference for it. We definitely seemed like everybody was okay with the first problem, so I'm going to go to these other two that sometimes cause trouble. And this middle problem where we're asking questions about the inputs and outputs of a function where there's no algebraic equation for the function, but rather we have a picture of the graph of the function, definitely feel different than when we have an algebraic equation. But don't forget that when you see f of a equal b, that just means that the input a gives us the output b. So that's what it means in terms of functions. And in terms of the graph, it means that the pair AB is on the graph. So that's the big connection between the function notation and the graph. So when we see a question like evaluate f of 3, the 3 is the input. So the input is the first coordinate. So we're looking at points that have first coordinate 3. And then the question is, what's f of 3? Well, that means I want the point on the graph when the input's 3. Notice that there's only one point on the graph when the input is 3. So the output when the input is 3 is 1, right? So this point right here is the point 3, 1. So 3, 1 is on the graph. Therefore, f of 3 equals 1. The harder question is, it's the second question, which is to solve f of x equals 3. It's not terribly different. It's just now we're being told the output is 3, right? So f of x equals 3, we're being told the b value here. We're being told the output b, which means we're being told the second coordinate on the graph. And the second coordinate is along this axis. So what I'm doing is I'm coming up to this point and I'm looking at where the graph is up here, and I can see that it only touches in one place as well, right here. Oops, not what I meant to do. So I have to kind of eyeball that, but I would say that's about the point, I'm going to call it 3.3, comma 3. And I have to just eyeball that first part because I only have the picture to work with. But just like before, a point being on the graph means that f of 3.3 is equal to 3. And I'll say approximately here because I did have to just eyeball it. So if you want to know the answer to this question, what x makes f of x equal 3, the answer is about 3.3. So try number 3, number 4 here by pausing the video. I'll count to 3 and then I'll do it. All right, so I'm going to erase the other things that I wrote here. I will leave my guiding principle up there, which is once I identify an input-output pair, then I know that point is on the graph. So now we want to know what is f of 2. And so again, refer to this notation. If I want to know f of 2, that means I'm being told the a is 2. In other words, I'm told the input is 2, which means I'm being told the first coordinate here. So the first coordinate being 2 means I'm coming this way to 2. And now I'm looking for the graph. The graph is only here. So this is the point that I need to look at in order to be able to talk about f of 2. This point has coordinates 2, comma, and then I'm going to say that's about negative 1.8. Right, so I'm not, I'm just kind of eyeballing over here about where that is height-wise. So my answer, I would say f of 2 is approximately negative 1.8. Because when you know a point is on your graph, that means that the input of 2 gives you an output of negative 1.8. Okay, and then finally, this last question I'm being asked, what input gives me an output of 2? So again, an output of 2 would be having a second coordinate here. Look, notice that there's actually 3 different points that do this. Get a different color here. So there's a point, and there's a point. So this question actually has 3 solutions. And to find them, I just need to identify the coordinates of these 3 points. So I'll say this first point is negative 1.7 comma 2. Again, I'm just eyeballing that first coordinate. I'm going to say the second point is negative 0.6 comma 2. And I'm going to say this last point is 3.1 comma 2. So all of those points are on the graph and have a second coordinate of 2. So my solutions would be approximately negative 1.7, approximately negative 0.06, and approximately 3.1. So that's my solution set for that equation. Notice that these evaluation questions, they always only have one answer. And that's what it means to be a function. The questions about solve could have one answer, could have multiple answers, or they could even have no answers. So we always like the evaluate questions better. Okay, the second question here is about x and y intercepts, and we talked briefly about this in class, but it feels a little different if you don't have a graph in front of you, so let's just do it for a couple of these examples. So for number 1, we know that what we're trying to identify here are the points on the graph that have one coordinate or the other equal to 0. And so there's 2 questions you could answer. You could ask to evaluate f of 0, and you could ask to solve f of x equals 0. So in the first case, I'm saying that we're going to make the input 0, and in the second case, I'm saying I want the output to be 0. So that's the difference between the 2 kinds of intercepts. If you don't remember which one's which, I would not try to commit it to memory. I would just think about where these plots sit. Like once you found them, then put a dot on a grid where they go, and you'll know which axis they're intercepting. So just like before, evaluating is an easier question. So at number 1, f of 0 is going to be 2 times 0 minus 1, which is negative 1. And so that means that the point, remember it's an input-output pair, input 0, output negative 1, is on the graph. If I peek up at the picture above just to have an axis, the point 0, negative 1 is right here. That's the point 0, negative 1, so that's on the y-axis. So that would be the y-intercept. So this is point, we would call that the y-intercept. Now solving takes a step, but it's not a hard step in this case. Solving f of x equals 0 means that we're solving the equation 2x minus 1 equals 0. Remember, I'm still working on this with this problem here. And we did this in class. To solve 2x minus 1 equals 0, you would get x equals 1/2. So therefore, that means that the point that has input 1/2 and output 0 is on the graph. That's my input-output pair. And once again, if I peek up here, the point 1/2, 0 is coming this way. Oh, this is not the graph of that function. I'm just using the axis here, so just ignore the graph. But 1/2, 0 is here, so it's along the x-axis. So if you can visualize where these points sit, then you'll know which one is which. So this would be the intercept of the x-axis. So we would do that for each one. There are times where solving can be hard, like these two guys. Solving can be a hard question for that because we haven't reminded ourselves about quadratic polynomials, but give it a shot and see what you remember. We will come to those later in the course. But for 1 and 3, we should be able to do both of these. Okay, the last kind of problem that you'll see in the Section 1.1 homework is just one that shows a bunch of pictures and asks which ones are actually graphs of functions. And the only property at play here is this property that I put in bold. We keep saying that a property of a function is that every input can only be paired with one output. And so there are some times where that doesn't happen if you just draw a scribble on a piece of paper. So this, for example, has a problem because if you look at the input of -2, remember the input would be the first coordinate. If the first coordinate is -2, and you look at the points on this graph, there are lots of them. There are 3 of them in this case. So it is not the case that every input is paired with only one output. In this case, if you had an input of -2, it could be paired with any of those 3 outputs that give you those points. So this B graph is definitely not a function. The rule that we learn for this is sometimes called the vertical line test. Because what's happening is, in this picture, there's a vertical line that cuts through the graph more than once. Not many of the other graphs do that. If you were to draw some vertical lines on these other graphs, you would see that the vertical line only crosses the graph once. That happens in A, it happens in C, it happens in E, and it happens in F. Graph D is the only other one that has this same issue. If I can draw vertical lines on D and see how it cuts through the graph twice. So D is going to be also problematic, that I have these multiple places where it cuts. So the way you can visualize it on a graph is just called the vertical line test. And the test is, if you can draw a vertical line that cuts through the graph more than once, then that picture is not the graph of an actual function. It seems like kind of a technical point for now. It'll be more important later on in our class when we get to exponential and logarithmic functions. And for those of you taking pre-calculus in the future or needing to see trigonometry, you'll see it again for trigonometric functions.